Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be discussing about another sorting algorithm is called bubble sort. Okay. Now in previous lecture, we have discussed about selection sort. Here, there we have seen that for in the first iteration, we were finding the minimum element in an array. Then we are just placing this minimum element at the start point, at the starting of the array, right? Then in the next iteration, we are finding the second minimum element, right? Second smallest element. Then we are placing at the index number 1, right? That was the flow. So in selection sort, we are finding minimum element and then we place at the beginning of the array. But in bubble sort, what we'll do, we'll do the opposite. First, we'll search for the larger element, the greatest element, right? Then we'll place that element at the last of the array. Okay. Then in the next iteration, we'll find the second largest element. Then we'll place at the second last position, right? That is the flow. Why the name is called bubble sort? Now, if you notice, so when bubbles form inside water, you will find that whatever the larger bubbles that are that size is larger than other, that will basically comes first in the top of the surface, right? So the bubbles that are large in size, that will come first at the top, then followed by the medium, then followed by the smallest. So that's why the name in the bubble sort algorithm also, first we find the largest element, then we place that at the end of this array, then followed by the second largest, then the smallest one, right? That's why it is the name is called bubble sort, right? So let's see how we can do this. So in bubble sort, what we do, so in bubble sort we are basically doing two things. We will compare the adjacent elements, and if we find the left element, so element at left is less than element of left plus 1, means the adjacent element, then what we'll do, we'll swap them. So basically two things, we'll compare with the adjacent element, then we'll swap this. So let's see how we can do. First, let's say this is the array. Okay, so first let's take let's change the color a little bit. Okay, so -2, then 45, then 0, 11, -9. Okay, now in the first step, what we'll do, we'll start from the 0th index. Okay, we'll start from beginning. Okay, then we'll goes up to here. Now first we'll come here, then we'll compare with the adjacent element. Okay, and what we'll notice, okay, so here it will not less than, it will be greater than. Okay, now if this element is greater than this, then only we'll swap. Now is -2 greater than 45 here? No, right? Then we'll do nothing, so it will be remain same, right? Then we'll compare this two. Okay, in step 2 we'll compare this two. Now we'll compare 45 with 0. Now is 45 greater than 0? Yes, right? Then we'll swap this two value. Why? Because we want the maximum value at the end, right? We want the maximum value at the end. Then what we'll do, we'll swap this two values. So 0 will be here, 45 will be here, right? 45 will be here. Now we'll compare these two values, 0 with 11. Okay, now sorry, now the element has changed to 45, right? Now the element is changed to 45. Now we'll compare 45 with 11. Is 45 greater than 11? Yes, right? Then also we'll swap this two value. Okay, so 11 will be here, 45 will be here, and here will be -9. Now this part is done. Then we'll compare these two values. Is 45 greater than 9? Yes, right? 45 greater than 9. Then we'll swap this two value. Here it will be -9. and here it will be 45. Now you can see the largest element is placed at the end of this array. Now we'll forget about this. We'll be doing the same operation for this part. For this part. Okay, for this part. For this part. Let's see. Okay. In the next step, what we'll do? Let's see this one. Okay. In the next step, let's write it minus 2, 0, 11, minus 9, and 45, right? This was the array. Now what we'll do? First, we'll compare these two values. Okay, we'll compare these two values. Now, is minus 2 greater than 0? No, right? Then we'll do nothing. We'll do nothing. Then we'll move to this two element. Is 0 greater than 11? No, right? Then we'll not swap. We'll not swap them. Then we'll move to here. Then we'll compare 11 with minus 9. Is 11 greater than minus 9? Yes, definitely, right? Then what we'll do? We'll just swap these two values. We'll just swap these two values. So minus 9 will be here, minus 9 will be here, and 11 will be here, right? Now, this part is sorted. Okay, now we'll forget about this part. Then in the next operation, what we'll do? In the next iteration, let's take another color. Okay, now in the next iteration, let's write it minus 2, 0, minus 9, 11, 45, right? This part is sorted. Okay, now in the next iteration, we'll compare them. Is minus 2 greater than 0? No, right? Then we'll do nothing. Then we'll move to here. Is 0 greater than minus 9? Yes, right? 0 is greater than minus 9. Then what we'll do? We'll swap this two value. So minus 9 will be here and 0 will be here. Okay. Now this part is completed. 0 is at the end. Now we'll forget this part. Then we'll move to next step. So in next step, it will be minus 2, minus 9, 0, 11, 45, right? 11, 45. Then what we'll do? First, we'll compare with these two values. Is minus 10 greater than minus 9? Yes, right? So then we'll swap these two values. So minus 9 will be at beginning and minus 2 will be here. Now you can see this array is sorted. This array is sorted now in ascending order. So at the end, this is the largest element followed by the second largest, and in the left hand side, this is the smallest element. So that's how bubble sort works. Now let's see visually how we can do that. So in the first step, we'll compare this two value minus 2 with 45. Then if is minus 2 greater than 45? No, right? Then we'll do nothing. Then we'll compare these two values 45 with 0. Now is 45 greater than 0? Yes, right? Then we'll just swap the values. So 45 will go here, 0 will be here, right? Then in the next step, what we'll do? We'll compare these two values 45 with 11. Now is 45 greater than 11? Yes, right? Then we'll just swap these values. Okay, right? Now 45 is here, 11 is here. Now we'll compare this to 45 with 9. Then 45 will be at the end. And so this is the first step. Then in the second step, so this part is sorted, right? This part is sorted. So in the second step, what we'll do? We'll compare first these two values. Is minus 2 greater than 0? No, right? Then we'll do nothing. Then 0 with 11. Is 0 greater than 11? No, right? We'll do nothing. Then 11 with minus 9. Is 11 greater than minus 9? Yes, right? Then we'll swap this two value. Okay. So this is the first step, right? This is the second step. Then in the third step, so this part of the array is sorted. This part of the array is sorted. So we'll do the same thing for here. We'll compare these two values. Minus 2 with 0. Is minus 2 greater than 0? No, right? We'll do nothing. Then we'll compare 0 with minus 9. Is 0 greater than minus 9? Yes. Then we'll just swap these two values. Okay, minus 9 will be here, 0 will be here, right? And in the next step, in the last step, what we'll do? So this part is sorted. We'll be comparing these two values only. Is minus 2 greater than minus 9? Yes. Then just swap them, right? Now let's say by code how we can write this. In the first step, what we'll do? So let's run a for loop for each step. So for, let's say, each step, and step will be varying from 0 to n minus 1. Okay, 0 to n minus 1. Okay, now each step what we'll do, we'll run another for loop, and that will be for j. That will be for j. Let's say we are at step 0. Okay, now we'll compare this with this, then this will this. Now if I goes to this point, now whom do I compare with? Is there any element at the right? Now if I access element at the right, it will give me an error of array index out of bound. So that's why we have to take a pointer j such that it will be, so if we take j, let's say j is here, we'll be comparing j with j plus 1. Okay, so let's say we are j at is at 0. Okay, then we'll compare 0 with 0 plus 1. Okay, then let's say we are at 1, j equals to 1, then we'll be comparing with 1 with 2, 1 plus 1. Similarly 2 with 3, and then 3 with 4. But if we are at this position, we'll do nothing, right? Means the j will be running from 0 to, so let's say j will start from here. Okay, from 0, then j will be start from here and it will stop here itself. And what is the index of this element? It is nothing but n minus 2. Okay, n minus 2. But this is for the first iteration, right? So for the first iteration, j will be going from 0 to n minus 1. But in the second iteration, what we'll do, we'll forget about this thing, then we'll iterate from here to here, right? From here to here. That's why in the next step, we'll be running j from here to here, right? J will be starting from, in the first iteration, this is first, and in the second iteration, let's remove this for loop. In the second iteration, j will be from 0 to what, n minus 3, right? N minus 3, right? This is clear. And in the, so this is clear, so this part is sorted. Then in the next step, what we'll do, in the third step, what we'll do, j will be running from 0 to n minus 4, like this. So if we are at step 0, so these are basically step. If we are at step 0, so step 0, let's remove this. Okay, if we are at, let's say write it as if s equals to 0, then we'll be running loop j from 0 to n minus 2, right? And then we'll compare this j element at j with j plus 1, right? Then when we are at step 1, then we'll run the for loop for j to 0 to n minus 3. That is basically nothing but n minus 2 minus 1, right? So here n minus 2 minus 0. Here we can write n minus 2 minus 1. And similarly for s equals to 2, we can write this is j will start from 0 and goes up to n minus 2 minus s, right? N minus 2 minus s. Okay. Now hope you have understood, right? Now what we'll do, so let's write the full code. First we'll run a for loop for, let's take s. S will be starting from 0 to n minus 1. Okay, then we'll run another for loop for j, and j will be starting from 0 to n minus 2 minus I, right? N minus 2 minus I. So I hope now you have understood why we are writing n minus 2 minus I. Okay, then what we'll do, we'll compare the current element with adjacent element. So we'll compare this ARR of j. If it is greater than ARR of j plus 1, then what we'll do, we'll just swap them. Swap ARR of j with ARR of j plus 1. So this is our operation. Right? So let's go to our VS Code and write code for this. Here is the array is given. Now to write bubble sort for this array, let's write a function called def and name it as bubble sort. Okay, then it will take an array, right? And then first step, what do we have to do? First, let's calculate the length of this array. N equals to len of arr. Okay. Then what we'll do? We'll run a for loop for steps, right? So for is in range, and that range will be starting from 0 and will be goes up to n minus 1, right? So that's why the range will be from 0 to n minus 1. That's why we are writing n here. Then what we'll do in the next thing, we'll run another for loop for j. We'll run another for loop for j, and for j in range. And what will be the range of j? So for each s, j will be ranging from 0 to n minus 2 minus s, right? So that's why we'll write 0 to n minus. So we'll not consider the last element. So in minus 2, so in minus 1 minus s, right? So range will be from this, right? So here you can see every time it will be goes up to n minus 2 minus s, and over here we're not considering the last element. That's why we're just writing this. And then in each step, what we'll do, we'll check. What we'll check, if error of j is greater than the adjacent element, error of j plus 1. Okay, then what we'll do, we'll just swap these two values. Okay, then error of j, swap this with j plus 1 equals to error of j plus 1, and then error of j, right? So this is our algorithm. Now let's call it. Okay, let's call bubble sort and pass this array here. Now let's print this array again, sorted array, pass this array here. Now let's run this. Now you can see initially it was minus 2, 45, 0, 11, minus 9, but here the result is in sorted error, right? First is minus 9, then minus 2, 0, 11, 45. So that's how bubble sort algorithm works. So I hope you have understood. Now here is a problem. So not a problem, basically we can optimize this bubble sort algorithm further. Let's try to understand. Let's say I am giving an array. Let's say 1, 2, 3, 4, 5, right? Now this array is already sorted. Okay, now let's apply bubble sort here. So what we'll do, first step we'll compare these two values, we'll compare them two values. Now if this is greater than this, then we'll swap, right? We'll swap. Now is this greater than this? No, right? Then we'll do nothing. So this is basically in step 0. So s equals to 0. Okay, we have checked this two element, and we don't have to do anything. We are not swapping this. Now we'll compare these two values. Okay, we'll compare these two values, 2 with 3. Now is 2 greater than 3? No, right? So we'll not swap. Okay, we'll move to this two element. Okay, now is 3 greater than 4? No, right? 3 is not greater than 4. Then we'll do nothing, we'll not swap. Then what we'll do, we'll compare 4 with 5. Okay, is 4 greater than 5? No, right? 4 is not greater than 5. 4 is not greater than 5. So what we have done here, so this part is now sorted. This part is now sorted. And how many swaps operation are there? So let's say swap, number of swap equals to 0. Number of swap operation is 0, right? So this part is sorted. Now when I go to the step 1, so it's equals to, let's say, 1. Okay, now it's, and what will be there? So 1, 2, 3, 4, and this part is sorted, right? 5. This part is sorted. Now again we'll compare these two values. Is 1 greater than 2? No, right? Will not swap. Then we'll compare this 2 with 3. Is 2 greater than 3? No, right? Will not swap. Then we'll compare 3 with 4. Is 3 greater than 4? No, right? Again we are not swapping. We are not swapping, but this part is sorted. So here also number of swap equals to 0. Now if we do the third step, s equals to 2, so second step basically, then what we'll do, we'll see. So if we compare 1, 2, 3, 4, 5, so if we compare these two values, then also we'll do nothing, we'll find nothing. then we'll compare these two values. So there also be there in sorted. So here also number of swap equals to 0, right? So what does it mean? Means, let's say, if any iteration for any steps, if I find number of swap equals to 0, means I'm not required to swap them. What does this mean? This means the array is already sorted. The array is already sorted. That's why we are not swapping. Then, do we require the steps? Do we require the steps? Do we require the steps? No, right? Because when we find number of swaps equals to 0, then we can tell that we don't need these steps. We can immediately say that this array is already sorted, then just remove from this loop or return from this function, right? So you can take number of swaps, or you can take this swap. We can take this swap as a boolean value. Let's say boolean. Let's say it is initially at false. Now, every time if you do any swap operation, you will change this swap variable to true. And if you don't find anything, then you will not change this. Then what you have to check? You have to check is swap false or true. If it is false, then immediately you can return back from this function. So this is called optimized binary search. Mean we are just counting the swap, or we are just maintaining the swap variable boolean value. Then every time we swap, we'll be updating this value. And in each step, if we don't find any swap, then we can immediately return back from the function, right? So let's modify this. So for to do this, in each step, we'll be taking a variable, let's say swap, okay, and initialize with, let's take a boolean value, let's take false initially. And when every time we swap this value, if we find anything and we swap this, we'll modify this value. So swap equals to true. We'll make swap equals to true. You can take swap as a integer value. Initially, it will be 0. When you swap them, it will be increment the count. You can do that. And every time, what we'll do, and in each step, we'll check if not swap, means if swap is already false, then what we'll do, we'll break this loop. We don't need to do the step 1, step 2, right? If the array is already sorted, so we don't have to do anything. Let's say initially the array is not sorted, but somehow at step 2 this part is sorted. So let's say at step 0, step 1 it is swapping, but in step 2 it is already sorted, number of swap is 0. Then from that we can remove this from this function, right? So that's how we can optimize our binary search, okay? And what is the time complexity of bubble sort? The time complexity of bubble sort is O of n square. Why? Because we are running two for loop here, right? And what is the time complexity of selection sort? The time complexity of selection sort is also O of n square. Okay, now I hope you have understood how bubble sort works and how to optimize a bubble sort. Now let's take a problem. This problem we have already solved using selection sort. Now let's solve it using bubble sort. So what is given? You are given an array, people array. So in this array, each element is not integer. It's basically a tuples. So here in this tuple, first element is basically name of people, then followed by the age. The second element is age. Then for the second person, it is the same name and then age. What you have to do, you have to sort this array by age, right? So let's write the code for this. So let's create a sorting function using bubble sort. Okay, let's name it as bubble sort, and it will take an array. Then what we'll do, we'll calculate the length of the array error. Okay, then we'll run a for loop for s in range will be from 0 to n minus 1, right? And then we'll take another variable, so swap, and initialize with, let's say this time we'll take an integer, and we'll create another for loop for, let's say j in range, and j will be ranging from 0 to n minus 1 minus this s, right? 0 to n minus 1 minus s. Then we'll check if, so what we'll check, previously we are checking error of j, right, with error of j plus 1. So this time we'll be checking error of j of 1 with error of j plus 1 of 1, right? Because we are comparing the age. So if we consider error of j, it will be a whole tuple. Then whatever the element, second element at index 1, that we'll compare with, right? So if this is greater than this, then what we'll do, we'll swap these two values, right? So we'll error of j comma, sorry, error of j plus 1 equals to error of j plus 1, then error of j, right? And we'll be incrementing the swap. Okay, swap plus equals to 1. Okay, then at the end, if swap equals to 0, then we'll just return. Okay, okay, or break, whatever you can do. Now let's call it, okay, let's call this bubble sort, then pass this person, sorry, people. Okay, now let's print the array, print people, and let's run this. So this is the code, let's run this. So here you can see, so first Bob, then David, because their age is same, 25, then Smith, then whose age is 30 is coming next, then at last Eve is 35, right? So that's how bubble sort works. I hope now you have understood this sorting algorithm, right? Now let's understand the bubble sort visually, how it actually happens. So let's say initially we are taking these elements 49, 20, 14, 37, and 14, right? So what we know in bubble sort, first this larger element will be moved to the last. How it will compare with the adjacent element, then if it is the current element is greater than the adjacent element, then it will swap the values. So let's see how it works. So let's click here sort. So initially you can see these two are compared and swapped, these two are compared and swapped, and at the last this large index large element is placed. Now similarly this process is repeating. So second largest element is placed, then the third, and lastly 14 and 14. So now this array is sorted. So uh, that's how bubble sort actually works. Now if you want to see visualize selection sort, so selection sort basically opposite to bubble sort. So whatever the minimum value, that will be goes at the beginning of the array, right? So let's run this. So you can see first minimum element it will be find, so it find that this 2 is minimum, right? Then it just swapped. So then it will find the next minimum element, then it will swap. Okay, now you can see this array is sorted. So this is a nice website called Visual Algo. So you can check it out. You can create what you want to visualize, right? So I hope you have understood what is bubble sort, what is selection sort. So that's it for today. See you in the next lecture. Thank you.